Walaikum Assalam. Walaikum Assalam. Walaikum Assalam. Walaikum Assalam. Yes, 2:35. Let's start. In the previous class, we were discussing about Walaikum Assalam. We were discussing about common ion effect, and actually, we were discussing the factors affect common ion effect, right? What will be the effect of common ion? In the previous class, we have said in presence of strong electrolytes, degree of dissociation of weak electrolyte is further suppressed. Already they are weak electrolytes. However, if they have been taken along with the strong electrolyte, their degree of dissociation will be further suppressed. That is called as common ion effect. Keep this concept in mind because when we start numerical discussion. This is very, very valuable information suitable for us to solve the problems. Come on. Now let us go. Wait a minute. Sayyid Yusuf. Right. To be removed. Sayyid Yusuf. Okay. Please, please, please come in the class with pant and shirt. You should remember your class name and you should remember your roll number. Otherwise, please don't come because नंगे classes में नहीं आया करते. Today we are having a new discussion. We are saying that acid plus water, acid ionization constant, Ka, base plus water, base ionization constant. So the word acid ionization or base ionization constant is nothing but actually equilibrium constant, but we use this word specifically whenever we are discussing that equilibrium which is available when you take the substance along with water. Okay, what is the meaning of this sentence? I am trying to say that I can attain equilibrium even without water also. Yes, sir. Go to Bronsted theory. In case of Bronsted theory, there is no necessity of water as a solvent. I can take any other substance. But if suppose you are taking water as a solvent and you are writing a possible type of equilibrium, for that equilibrium, people say acid ionization constant, base ionization constant, right? Okay. If it is so, what is happening? Nothing is happening, sir. Acid ionization constant means water will ionize the acid molecule. Water will ionize the base molecule. If suppose, for example, you are thinking on these lines, then let us create a very beautiful discussion. That is, suppose, for example, if I am having water along with water. Yes. Right? What I said just now, water along with acid, water along with base. Now I am taking water along with water. And if you allow this reaction to proceed, and if you enjoy the concept of Bronsted theory, what will happen? Very simple, sir. One fellow will behave as a donor, other fellow will behave as an acceptor. According to Bronsted theory, water has a property of an acid, water has a property of base, and they are supposed to be, that is supposed to be amphoteric character of the water molecule. In this case, what happens? The water molecule which is gaining H plus ion becomes hydronium ion, and the other water molecule becomes OH minus, right? And this is basically nothing but formation of conjugate acid base pair. And whenever you are having formation of conjugate acid base pair, according to Bronsted theory, we say, sir, it is a very good example of neutralization reaction. Yes, under the concept of Bronsted theory, it is of course a very good example of what? Neutralization. However, today my discussion is not neutralization, that is already over. My discussion today is, suppose for example, if we take water along with water, then here in this case also we can write a reaction or an equilibrium process which may be considered as the ionization of water using water molecule. Ionization of water using water molecule. And if you think it seriously, you can come to a point, sir, are you not talking about self-ionization? Yes, I am talking about self-ionization. Water molecule is ionizing to water molecule. This is known as self-ionization process. This is known as autoprotolysis. Protolysis is breaking of substance to release a proton. Auto, self, right? By itself, no other agent is required, as you said in earlier case. Therefore, if suppose you discuss that, then for this equilibrium reaction also, there must be some constant. What is that constant? Equilibrium constant, dissociation constant, ionization constant. This K is written as usual with respect to that normal value what we have done yesterday. Equilibrium constant, let us say dissociation constant is equal to concentration of hydronium ion. You know that this is nothing but H plus ion concentration. Scientifically, I should say hydronium ion, but basically it is H plus only, right? Into concentration of OH minus ion by what? What is here? Concentration of water, H2O, into concentration of water, H2O. This is normal method. I am a normal student, therefore I am behaving like this. But when I go in a systematic approach of notes, and if I have read notes, then what I say, no, sir, you should not write this water molecule here, because you know that active mass of water is taken as 1, right? That means this water is taken as a pure liquid. Sir, if it is pure liquid, why don't you take that one also? We have to remove this water molecule also. No, one is undergoing ionization. The substance which is undergoing ionization is the friend, whereas the substance who is responsible to to undergo ionization process is medium, is solvent. Acid plus water, water is solvent. Base plus water, water is solvent. Water plus water, one water is solvent and one water is solute molecule. And for that solvent which is taken, that water molecule which is taken as a solvent, I have to write active mass. Therefore, the equilibrium constant is equal to molar concentration of H plus ion into molar concentration of OH minus ion by concentration of water, which is behaving as a solute in this case. Nice. Once you have this one, then the question is, sir, concentration of water. What is concentration of water? Doctors, a 4 marks question for you. What is that? We have done it in stoichiometry. Find molarity of water in pure water. Right? A very beautiful question, and indeed it has been asked in what we can say your MSET examination. Once it has been asked, but we don't use as a question here. We do use this as a tool for solving so many type of questions. Right? Come on, how to proceed for that? Very simple, sir. If you want to find out molarity, we have ready-made formula. Let us go for that one. What is that formula? Molarity is equal to weight by gram molecular weight into 1000 by volume of solution in milliliters. Sir, in the question, nothing has been given. No, no, there is something hidden in this question. And what is that hidden thing? Density of pure water is to be taken as 1 gram per ml. Right? Now, what is the meaning of word 1 gram per ml? The meaning of word this is to understand it. Basically, understand it. What is the meaning of this? Whenever you take 1 gram of water, this should occupy 1 ml. Wherever you take 1 ml of water, this should weigh 1 gram. That is the meaning of word density. And if you understand that, let us apply this one here. That is, molarity of water in pure water is weight of water solute 1 gram. And this is molecular weight 18 into dash 1000 by what is volume? Volume is also 1 ml. Therefore, we get answer 55.55. People try to memorize this word that molarity of water in pure water is taken as 55.55. Right? Now, once you have this one, then it is a constant quantity. And once hearing it is constant quantity, then let us see how to proceed. This is capital K. What is that K? This is known as dissociation constant. This is known as ionization constant. And if suppose, for example, you are taking this to be as dissociation constant, better to say ionization constant, into concentration of water, it is a constant. Right? Now, the word is called dissociation constant or ionization constant because we are ionizing water molecule. But remember, a very beautiful name is technical name available here in this case is, it is called self-ionization constant. Yes. Basically, dissociation constant. Basically, ionization constant. No, no, sir. It is a self-dissociation process. Therefore, it is known as self-dissociation constant. Some authors, some lecturers enjoy this as KSIC, self-ionization constant. Right? Now, once you are having this one, then this into K into concentration of water is equal to concentration of hydronium ion into concentration of OH minus ion. This is a constant. This is a constant. When you take both of them as a constant, we get a new constant. Let us say, for example, K. And what is the name? Let us enjoy the name just now. It is concentration of H plus ion multiplied by concentration of OH minus ion, right? And what is this? Now take a look carefully here. Product multiplication. Product of molar concentration of ions of water. What is this K? This K is known as product of molar concentration of ions of water, right? Product of molar concentration of ions of water. Therefore, people call this as ionic product of water. Today our heading is ionic product of water. And its symbol is dash Kw. Ionic product of water, it is called as Kw. Okay, nice. Two 45 is our log per meter. Now this is known as Kw. Fine. Once you understand the word Kw, then the question comes, sir, what is actually Kw? It is also a type of equilibrium constant. It depends upon nature, temperature, right? Now, sir, what is the meaning of nature of water here? We are having water, okay? Kw for rainwater, Kw for river water, Kw for tap water. As you are changing the nature, sample of water, Kw value changes. No, no, sir. It also depends upon temperature. Of course, it depends upon temperature also, right? Kw is called ionic product of water. Okay. By the way, suppose, for example, if I want to say, sir, this is ionic product of water. Therefore, shall I say like this? This into this. What is this? K, dissociation constant, common name. I'm enjoying self-ionization constant into concentration of water. What is that? 55.55 is equal to dash ionic product of water is equal to concentration of H plus ion into concentration of OH minus ion. Apart from nature, right? We don't change the word nature here as I am explaining that river water and rainwater. No, no, let us take, sir, normal one sample, one type of sample. If it is so, Kw should depend only upon temperature. How does it depend upon temperature? Let us enjoy that one. Right? At 25 degrees centigrade, it is observed that numerical value of Kw is 10 power minus 14 mole square per liter square. You can also write molarity square because you are having concentration of H plus ion, moles per liter, moles per liter. Similarly, if suppose, for example, you are taking, sir, I am having 90 degrees centigrade temperature, Kw, right, is 10 power minus 12 mole square per liter square, right? What is happening? As you're increasing temperature, the numerical value of Kw also increases. This implies as temperature increases, numerical value of Kw also increases, right? If I say so, you can say, okay, sir, fine, I'll accept, but any reason is there? Any scientific approach is there to say, yes, if you increase temperature? Yes, it is there. And you have done it in the previous classes in chemical equilibrium. What is that? Log K2 by K1, effect of temperature on equilibrium constant. Now I should not say K, I should say log Kw2, ionic product of water at high temperature, ionic product of water at low temperature. Recall your notes, log K2 by K1 you have written is equal to, something was there. What is that? Delta H by 2.303 R into, are able to recall? Yes, 1 by T1 minus 1 by T2. T2 is higher temperature, T1 is lower temperature, delta H. In that chapter, you said enthalpy of reaction. Now you have to change your tone and you have to say, no, sir, it is enthalpy of ionization. Better to use the word molar enthalpy for 1 mole. It is molar enthalpy of water, right? Not water, sir. Let us further expand the sentence. Molar enthalpy of ionization of water. Very good. It is called molar enthalpy of ionization of water. Okay. If you say so, Naturally, remember that this must be always a positive quantity, because if you want to ionize a substance, you should supply certain amount of energy. Therefore, delta H more than 0. This is positive. This is also positive because T2 is always more than that. This means log Kw by K1 is positive. This proves that as you increase temperature, Kw value also increases. And as you increase the temperature, Kw value increases. This is the effect of discussion. In continuation, to go back to previous class, what was the my target actually? Quantitative study of H plus and OH minus ion. We said acid is strong, base is strong, acid is weak, base is weak. How much weak? How much strong? If you want to do so, we are in need of H plus ion. No, 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 sir. We are in need of alpha. We started with discussion of alpha. We defined alpha. We enjoyed the concept which is affecting the alpha. Then now I am switching over to H plus ion concentration. For that, I need a tool called Kw that I have taken. Using this Kw, let us try to understand what is the meaning of comparison of acids and bases with respect to H plus and OH minus. Take down this, then we'll proceed. Go ahead. If it is over, intimate me, I'll proceed. Done. Now, by the way, let us enjoy one question. This is a IIT mains question, but nowadays the doctors are also so much standard level students that we can enjoy that IIT mains question for this. Suppose, for example, if I say Kw, what is that? H2O plus H2O gives you H3O plus and OH minus. This is called self-ionization constant or constant self-ionization process. Kw is written as H plus into OH minus. Suppose, for example, one of you says, sir, is it necessary that you should take only water? Can't you apply this concept for any other substance? If I ask a question, which type of substance? You can simply say, sir, you are taking one water molecule in such a way that one fellow is behaving as donor, other is behaving as an acceptor. If this property is also available with any other solvent, yes, your thinking is right. Suppose, for example, if I take any other substance, for example, let us take ammonia. This question has been asked number of times, right, in grand tests of different well-known academies along with IIT examination also. Suppose if I take ammonia versus ammonia, then one ammonia will lose a proton, amide ion is formed, the other ammonia will accept a proton, there is a formation of ammonium ion. What is this? Self-ionization of ammonia. Any solvent, any polar solvent can do this job. We are specifically taking care of water molecule because he is one of our best friend because of its high dielectric constant. It is used as a universal solvent. Otherwise, it is possible for any other polar solvent. Therefore, KSIC, self-ionization constant of ammonia, should be written as, what is that? Product of molar concentration of ions of ammonia, like that. So, as we say, it is concentration of amide ion into concentration of ammonium ion. Okay, right. This circle is not necessary here. You can write like this, right? Like this, you can go for acetic acid, you can go for formic acid. Say, for example, one fellow asks a question like this: formic acid. One examiner created a question: formic acid is made to react with formate ion, formic acid. One will be losing a proton, formate ion. One will be gaining a proton, HCOO, H2 plus protonated formic acid. Who is this fellow? Protonated formic acid, right? Therefore, self-ionization constant of formic acid may be given as concentration of formate ion, one with loss of proton, one with gain of proton, HCOO, CH2 plus. Please take down this, then I'll change the slide. Go ahead. We are considering one molecule of ammonia. Doctor, no, not doctor, scientist Jasim. We are considering one molecule as a solvent, one molecule as solute. Who said I am not considering that one? As I said here, same concept applicable for all the remaining three. Yes, one is behaving as solute, one is behaving as solvent. Exactly same situation as applicable in case of water. What is ammonia? Non-aqueous polar solvent. Yes. What is formic acid? Non-aqueous polar solvent. Concept is same for both of them. Is it over? Fine. Come on. Come to next topic. Once you are understanding that I got an idea of self-ionization, right? Now see that slowly I am moving towards number game. 10 to the power minus 14. Till now, Arrhenius theory, Lewis theory, Bronsted theory, qualitative approach. Now we are trying to understand in terms of number game, right? And for that, suppose for example, you are saying, sir, at 25 degrees centigrade, Kw is 10 power minus 14. No, 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 no. It is concentration of H plus ion into concentration of OH minus ion. Sir, actually, I want to talk about what is H plus value. Okay, let H plus ion concentration be X. If it is X, naturally, concentration of OH minus ion must be also X. Therefore, we say Kw is equal to 10 power minus 14. No, 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 X square. Therefore, concentration of H plus ion or concentration of OH minus ion is equal to root of 10 power minus 14, 10 power minus 7 moles per liter. Now I got some number here, 10 power minus 7 moles per liter. But the question is, to whom this number is to be applied? Pure water. And who is pure water? Neutral substance. Therefore, for pure water, no, no. Pure water is neutral. Therefore, instead of saying for pure water, shall I say neutral substances? Yes. Those solutions which are to be declared as neutral. Now, here the neutral word does not mean to say electrically neutral, positive, negative. No. Here we are saying acids, bases, neutral. Acids are those substances which gives you H plus ion. Which gives you H plus ion means it does not mean to say OH minus ion is not available. Domination is with respect to H plus ion concentration. Sir, this fellow is a base. It means it is having releasing tendency of OH minus ion. It does not mean to say it is not having H plus ion. Every aqueous solution has both of them. But depending upon who is dominating, we are giving a label to them. H plus ion is dominating with you. Come on, I'll call you an acid. OH minus ion is dominating in you. I am calling you as a base. If suppose, for example, someone stand and say, sir, I am having both H plus and OH minus ion equal. Okay, I'll give a label to you, neutral substance, neither acid nor base. Acid and base both, that is different. Amphoteric is different behavior. Neutrality is different behavior. Remember that. Neutral substance means it should have H plus ion, it should have OH minus ion, but equal in number. So for pure water, if you discuss, we are having neutral condition. Therefore, we say for pure water, okay, let me enjoy the language like this. For pure water or for any neutral solution. This is not electrical neutrality. Neutral solution. Remember, H plus ion concentration must be equal to OH minus ion concentration must be equal to 10 power minus 7 moles per liter. Okay, okay, sir. Now I am having an idea. I got a very good strategy here that, okay, if suppose, for example, concentration of H plus ion is dominating to the reference value more than 10 power minus 7, it means to say it must be acidic substance. What is the meaning of more than 10 power minus 7? I can go 10 power minus 6, minus 5, minus 4, minus 3, minus 2, and 10 power minus 1. For all those solutions in which H plus ion concentration ranges from 10 power minus 1 to 10 power minus 6, I should say solutions are supposed to be acidic in nature. If H plus ion concentration is more, solution will be dash acidic in nature. Now, again, I am saying acidic or basic, as I said in case of Bronsted theory and Arrhenius theory, but now I am talking in terms of number. 10 power minus 6, 10 power minus 4. I can have a comparative account, 100 times weaker, 100 times stronger, like this. Similarly, suppose for example, if someone says, sir, H plus ion concentration is less than 10 power minus 7. Who is dominating? OH minus ion is dominating, but we take reference value always throughout the chapter as H plus ion concentration. Wherever there is a necessity, we enjoy with OH minus ion also, but general discussion with respect to H plus ion concentration, if it is 10 power minus 8, minus 9, minus 10, minus 11, 10 power minus 12, minus 13, and 10 power minus 14. Our limit is up to that at 25 degrees centigrade. If it is so, the solution is supposed to be basic in nature, will be basic, right? Okay, now we have an idea, sir. If suppose for example you are saying that if I want to take a reference value, I can take H plus ion concentration, and that is applicable exactly at a point which we are saying at 25 degrees centigrade. This means to say our reference of 10 power minus 7 is not applicable always. What is the meaning of that, doctors? A solution whose H plus ion concentration is equal to 10 power minus 7 is always neutral. It is a false sentence. It is a wrong sentence. It is true only at 25 degrees centigrade. If suppose for example you change the temperature, reference value also changes. How it changes? Let us try to enjoy first. If suppose you are saying this one, then H plus ion concentration is less than 10 power minus 7, more than 10 power minus 7, equal to 10 power minus 7. Reference is 10 power minus 7. Here you are saying it is a basic solution. Here you are saying it is acidic solution. And here you are saying it is neutral solution. No, sir. I have changed the strategy. And I said, no, no, no. At 90 degrees centigrade, what is the value of Kw at 25 degrees centigrade? Kw is 10 power minus 14. I have taken the reference like this. Now, suppose, for example, if I take this one, the numerical value of Kw is 10 power minus 12. Therefore, now I should say criteria for neutrality or acidic basic character is H plus ion concentration less than 10 power minus 6, right? More than 10 power minus 6, equal to 10 power minus 6, right? The reference has been changed, right? This solution is called as basic solution, this is called acidic solution, and this is called neutral solution. Therefore, remember that always if I say H plus ion concentration is 10 power minus 7 is neutral, not correct. It is applicable only at 25 degrees centigrade. Fine. Once you understand this, then you are happy. Yes, sir, I got an idea that how do you have comparison of quantitative comparison of acids and bases, 10 power minus 6, 10 power minus 4. Who is stronger? How many times stronger? 100 times or 10 times? Okay, I got it. But there is a problem. What is the problem? The problem is, suppose for example, if you are saying that H plus ion concentration is 10 power minus 1, what happens now? At 25 degrees centigrade, range of H plus ion concentration for any solution is 10 power minus 1 to 10 power minus 6 minus 7, 10 power minus 8 to dash 10 power minus 14. If it is so, you are of course happy that you are able to do comparative account, but one scientist said, no, 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 it is not advisable because 10 power minus 5, 10 power minus 10, 10 power minus 13, they are too small numbers. You cannot have any appreciable comparative statements. You cannot enjoy the beauty of comparison if you are dealing with too small values. right? If suppose, for example, if I'm having comparison like this fellow X is having 1 rupee, Y is having 1 rupee 25 paisa. Yes, we are having comparison, but that is not an appreciable way, right? X is having 1 lakh rupees and Y is having 20 lakh rupees. Yes, sir, this sounds very nice to understand the comparative account. Like that, one fellow by name Sorensen, he identified this problem. He said that no, this is not a beautiful way to enjoy the comparative statement. For that purpose, he said, I'll give you one expression for MS students, and he has given a expression. That expression is known as pH. The way of writing pH, roll number X, roll number Y, right? Roll number Z, all are beautifully wrong. What is correct? This is the line of your notebook. This is a small p and this is capital H, pH. But remember, writing pH in this way will not give negative marks, but beauty is different, discipline is different, and randomness is different. pH of solution. What is the meaning of pH? pH means potential. It's some different name is given, but the English meaning of this sentence is, don't say full form, right? I enjoy the term potential of hydrogen ion concentration. Potential of hydrogen ion concentration. Sir, what is the meaning of this word potential? Go back to your physics class. What they say? Potential. What is potential? Level, right? It is called level. Water moves from higher level to lower level. Electric energy flows from higher potential to lower potential. Potential means level. Here we are trying to enjoy level of H plus ion, and what Sorensen suggested, that pH of a solution should be given as minus log of H plus ion concentration. No, 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 no. Wait a minute. Okay. Minus log of H plus ion concentration. Some people say, no, sir, remove that minus sign and write down log of reciprocal of H plus ion concentration. Right. Similarly, let us enjoy the game POH. What is POH? Now cheating. Minus log of OH minus ion concentration is equal to log of reciprocally. People are mathematically genius. OH minus ion. Similarly, pKa, all right? Don't go on wrong side. Minus log of Ka. pKb minus log of Kb. And pKw minus log of Kw. These are the expressions which we can learn with the concept of pH. Now, sir, how it is useful to enjoy the concept of pH, to understand and to enjoy the beauty of comparison, which we are in search since last 3 days. Okay, come on, how to proceed? Let us enjoy the game like this. Let H plus ion concentration of solution is 10 power minus X. Suppose, right? Molar. If it is so, what is pH? Very simple, sir. Doctors. Minus log of H plus ion concentration. Right? In logarithms, what do you say? That this X, why unnecessary bracket? This X, right, comes here, and then it is log 10. And what is log 10? Log 10 is 1. Therefore, answer is X. Okay, okay, right? We have to calculate this. No, sir, we don't have that much time to calculate. What to do? If suppose, for example, I am saying H plus ion concentration is 10 power minus 3 molar, just write down this 3 as it is. Finished. Answer is pH is equal to positive power. But, right? It is only applicable when you are having 10 power 3, 10 power 2, 10 power 5. But if suppose there is some other number, be careful, be careful. Don't rely always upon shortcuts. If it is so, pH is equal to minus log of 10 power minus 3 is equal to 3. Okay, if it is so, what is the advantage and beauty given by Mr. Sorensen? Okay, 10 power minus 1, 10 power minus 2, 10 power minus 3, 10 power minus 6, 10 power minus 7, 10 power minus 8, and dash 10 power minus 13, 10 power minus 14. Okay, now let us take pH value. What will be the value? 1, 2, 3, 4, 5, and so on. Therefore, if suppose for example you are having a solution whose H plus ion or OH minus ion concentration is known to you, you can say, sir, I can calculate the value of pH also, and pH is changing from 1 to 14. And if it is so, then now you can say pH is from 1 to 6. Solution is acidic in nature. pH is from 8 to 14. Solution is basic in nature. And if suppose pH is equal to 7, solution is neutral. Therefore, now we have a clear idea. 1, 2, 3, 4. I can enjoy the comparison. Instead of saying 10 power minus 2, 10 power minus 3, it will be slow number. Therefore, remember that depending upon this, we can enjoy the game. But there is a beauty in this game to get 4 marks, right? pH of a neutral solution is always 7. Okay. Question is true or false? Remember, this is a false statement because 10 power minus 14 is not a constant value. Therefore, remember, what is the conclusion? Conclusion is very simple, sir. pH scale proposed by Sorensen is dash dependent, temperature dependent. Yes. How to enjoy the remaining part? First write down this, then we'll proceed. Any question to ask? Heading write down pH scale. Nowadays, no one is asking who has given. That was a 1947 love stories. People used to ask who has given and all that. Nowadays, simply concept-oriented discussion. Heading write down pH scale and go ahead. JL40 roll number 20. You are seeing alone and you are not writing. हाँ अब अपनी वी आर सीइंग बेटा, यू आर नॉट राइटिंग नोट्स. आपका नाम पूरा नहीं आ रहा स्क्रीन पे. आप वीडियो ऑफ कर दीजिए क्योंकि आपके ऐप खुल के आते हैं मेरे सामने. पूरा लिखो बेटा, पूरा लिखो. चलिए चलिए चलिए, वीडियो मत ऑन कीजिए, आप अपना काम कीजिए. लिख रहे हैं, वेरी गुड, एक्सेलेंट. अगर आप रुक रहे हैं, कहीं डाउट है? वेरी गुड, एक्सेलेंट एक्सेलेंट. Why you are stopping your pen? If you have doubt, please ask. Please ask. No doubts? Excellent. Go ahead. Go ahead. Shoaib, go ahead. Done. Very good. Fine. Oh, we cannot continue because we have less amount of time, right? That will stop here. We have a tool now. Instead of going to H plus ion, we are referring to pH of solution. How you have to find out the pH of different solutions? That is our next question. As we are improving, we'll create questions as a scientist and we'll try to answer. That is called as teaching and learning. Thank you. Assalamu alaikum.